Right. Hi, everyone. I'm Bharath. I work for Roku for the data platform team, and I'm here to talk about our journey of designing the next gen data catalog at Roku using Gravitino. So we were initially Hive-based data store. So we had a lot of Hive tables. We still have. We are migrating to Iceberg. So as part of this, we chose our catalog as Apache Gravitino. So this session explores our journey of this transition, and specifically, it focuses on how it solves the case of authorization and authentication, and how it improves our security aspect as well with this migration, right? So let's get started. So we all know about auth, but just to give a primer, authentication is who you are, right? Like it proves your identity. Basically, mechanisms like username and password, API keys, OAuth tokens, SAML certificates, etc., single sign-on. So we all have used one of this at some point, right? And authorization is what you can do, right? This typically happens after authentication. You access some resource on a resource server, and the authorization provider would validate your permissions, like typically role-based access control, or some policy engine externally, like OPA or SQL grants, or in the cloud case, we typically use IAM policies like service accounts on AWS, Azure, or GCP. So that's just a primer of auth. So to explain this journey, like initially we had like legacy metastore authorization. So we were using Hive tables, and our metadata was all in Hive metastore. So with metastore, our identity was static. For example, if you were running a Spark job, our jobs typically was using the JVM username or the username for the Docker pods where the job runs. So there was no like per user authentication as it runs on a shared machine user. And in Trino, it was slightly better because it uses impersonation. So the users would sign in through some BI tool like Looker or Superset, and Trino gets that username and it impersonates the operation as that user. So we could at least get user level information in the metastore to do the authorization, but still it lagged like something like an OAuth level of authentication. And in terms of access control, we used the metastore based SQL standard auth. So it had only like table level grants, which means there is no like schema or catalog level permission grants. So it was like a flat model in terms of authorization. So you can see like there is no unified control, right? Like Spark and Trino work sort of differently, and there is some inconsistency across the security model. And so in Spark, because we couldn't reliably use the username, we were relying on the service account permissions of the pod where it runs to actually do the authorization at the object storage level. So it was like there is no uniform mechanism. And we were also using permanent credentials, which means that for the service accounts that run the jobs or queries, we need to give a static permission on every client. So there is no like short-lived tokens or credential vending, which are like modern ways to do the fine-grained authorization. So these were like our legacy setup. It worked, but it, of course, it had its own gaps. So we'll see how we solve these problems using Iceberg. Yeah, so we will now see how we solve these problems using Iceberg and Gravitino. So to give a introduction about Gravitino, it's a catalog for Iceberg. So Iceberg, as you all know, is a table format. Mostly we are using it because it has a lot of new features, right? Like branching, partition, time travel, and it has like a better structured metadata. And they have like nested metadata layers, which helps in partition pruning and a lot of optimizations when you come from a legacy metadata layer like Hive and Hive Metastore. So Iceberg also exposes a REST spec, which is implemented by the catalogs to store the metadata. So one of the popular catalogs out there is Gravitino, which is open source. So we went with Gravitino because it's open source and it also provides a better case for us in terms of our auth journey as well. So main features with respect to this authentication are that in Iceberg, OAuth 2 is preferred, and it's also part of the Iceberg spec itself. So using OAuth 2, typically you have two cases which we'll discuss, which is like human auth and how it works with non-human, that is machine or like client automation authentication, where there's no user involved. And then for authorization in Gravitino, we use the role-based model. It's kind of similar to Hive, but it's an improved model where we have like user role privilege mapping, and they also support hierarchical grants. Like if you have access to a schema, then you already inherit those permissions to the table. So we can have a hierarchy of grants, and also there are overrides allowed where you can manually revoke a permission. So it offers more fine-grained access control as well. And like I mentioned earlier, credential vending is one of the useful things because it allows us to vend short-lived credentials. So you don't need to grant a permanent permission on a GCS or S3 path for a client reading that path. When the client does a read or write operation, the corresponding credential is vended by the object storage through Gravitino, and the client uses that credential to do the operation. And so this provides us this unified access control, like a single way of authorization and authentication for all our query engines like Trino, Spark, JDBC clients, and Flink. And we use the Gravitino with the shared entity store, which is MySQL. So I want to walk you through different cases of authentication challenges and how we solve it. So in this slide, you can see our setup for Spark dev environment. So in our dev environment, each developer has their own namespace, and they use it to run ad hoc jobs or run some DAGs before they deploy to production, right? So they have their own dedicated namespace to do the tests. So here we need a per user authentication. So the OAuth token should be generated for the user. So how it works in this case is that the developer runs a one-time auth script that would open a browser for logging into your identity provider. Here in this case, we use Azure. So I've shown that in the slide. And for human login, we use something called a authorization code with PKCE flow, which is like proof key to code exchange. You might have seen that at some point, right? You enter a code which the IDP provider prompts, and then you log in. So this is a mechanism by which a human can log in using the OAuth flow. And the good thing about it is you don't need a client secret on the developer machine if you follow this protocol. So what happens here is that I have a demo after this to show how it works, but once the user logs in, the identity provider returns a token, typically an access token and a refresh token. So access token is a short-lived token, typically for an hour or so, and you can use the refresh token to generate a new access token, right? That's how typically all the OAuth flows work. And in our case, once we get these tokens, we store it in the Kubernetes secrets, and then the jobs use our Spark operator. So before running the job, we extract the tokens from the secret and generate a new access token and put it in the Iceberg config so that the Spark operator has a fresh token before running the job and it executes the job with that token. Now, as part of Iceberg REST APIs, Iceberg automatically attaches this token to the catalog, which is Gravitino. So Gravitino receives this token and it does the authorization. It extracts the username, validates the token, and does the authorization. So here you can see end-to-end the user identity is propagated in a secure way, and it's also validated and used for authorization, right? So let me show you a quick demo. So here you can see I'm running like the one-time script. So it will basically open up, so you can see it generates a code and it opens up a browser to log in. So you paste the code and once you log in, um, the script would put your access token and refresh token in the Kubernetes secret. Now, once that's done, if you run a DAG in this namespace, like I mentioned, the custom operator that we built would inject the token into the config so that users just need to do this login one time, and the refresh token is valid for 90 days. So they just need to run the script once in 3 months, and after that, it works on its own. So here I created a test DAG to run on my dev namespace, as you can see here. It's like namespace on my name, and this DAG just creates a table. So I ran this DAG, and in the Gravitino UI, you can see it created a table. And the main thing I wanted to show like is the username here, right? So we can see that the table is owned by me. Earlier, we could not achieve this. The table owner would be like Spark or some shared user, even if we run in a shared dev cluster. I mean, a dedicated individual dev cluster per user. So this is a great improvement for us. So in production, I have a different flow to explain. So the difference here is in production, the identity is per team. It's not per user. So each team gets a dedicated namespace and also a dedicated Azure AD app. So each team has a client ID and secret. And here no user is involved, right? Because teams run jobs at their cadence and it's scheduled to run forever. So here the auth works a bit differently. The client ID and secret is stored in Kubernetes secrets in the team's namespace. And our modified Spark operator mounts these and injects them in the Iceberg credential property of Spark config. That's the client ID and secret. So in this case, the operator does not fetch or generate the token itself. The Iceberg itself handles this natively. When Iceberg REST client initializes, it sees the credential config and it runs the client credential grant against the OAuth server and gets the token. And then it manages the full token lifecycle. So the important difference is that you can't have a per user identity here, which is not needed. But here no human is involved. So these are two kinds of flow in OAuth. One is like user interactive flow, and this is like a client credential token flow, which is fully automated. So we use this flow in production. So yeah, to just summarize these two side by side, you can see that we discussed about the authorization code plus PKCE flow and the client credential flow. And in the first one, the good thing is you can get a per user identity, but in the second flow, you can only get a per team or per app identity. And the benefit there is that you don't need a human interaction. It's fully automated, and in the dev flow, which I showed, you need a one-time browser login. So these are like common auth flows in the industry, and you need to choose whichever applicable to your situation. So there is one more challenge that we faced. This is with Trino. So this Trino has a unique challenge. In Trino, we don't have a user interaction, but we still need to get the per user token. So what happens here is when we set the session equals user as a config in Trino, Trino itself builds an unsigned per user JWT token. But this is generated by Trino itself. It's not generated by any standard identity provider, right? So this has no signature. So if I present this token to my identity provider, which is Azure, it has no idea what to do with this token. So to bridge this gap, we built a lightweight token exchange proxy that sits between Trino and Gravitino. So here's the flow. Trino sends a request with two things to the proxy. One is an actor token, which is which tells the proxy that it's sent from Trino, right? So it means like I am Trino and I want to generate a token for this identity, which is a user. So in this case, it's like subject is Bharath and Trino attaches its own token. So proxy validates this and generates a proxy token back to Trino. So what happens here is that Trino uses this token to talk to Gravitino. Now, the second challenge is Gravitino should understand both kinds of token. So Spark can send token from Azure AD and Trino can send token from the Exchange Proxy. So we built a custom token validator in Gravitino, which can understand both these tokens. So this multi-token validator can accept proxy KS token and also the Azure token. So this way, we could make it work end-to-end, where Gravitino receives an OAuth token in all cases, where we can also preserve the user identity in cases that we need. So yeah, this is the whole picture of our high level workflow. You can see that Spark and Flink directly talk to Gravitino of IRC, and Trino, we have a proxy in the middle to do this token translation. So yeah, this is how we actually migrated the auth layer to Gravitino. So we evaluated the privilege model differences. There, it is not one-to-one mapped, but there is subtle differences. In Gravitino, there is only roles. So in Hive, we had users and roles. So users and role level permissions. So we had to create per user roles like user underscore Alice for a specific user Alice. We had to create that role in Gravitino for all users. And also Hive did not have any privilege inheritance, like I mentioned. It was flat table level grants. So since Gravitino supports it, schema level grant propagates to all the tables in that schema. That's a big simplification that we could use. And I have listed some of the privileges here. It's almost similar for insert. It's modify table. Insert, update, and delete would map to modify table. And for grant all in Hive, you need to give select and modify. So we had to create this mapping and create a migration script that would migrate all these permissions to Gravitino and also create all the users in Gravitino, right? This is a one-time setup that we had to do. And for incremental grants, we also had to create compatibility wrapper to apply these grants from Hive to Gravitino. So yeah, that's so this captures all the transformation we discussed in one view. Before we used JVM username as identity, static IAM credentials on every client, and HMS SQL standard with no credential vending and stuff. Now we have OAuth tokens, real per user identity, and dynamic credential vending with the short-lived tokens and unified RBAC across all the engines. So this shift is not just a tech upgrade, it's like fundamentally changes our security story. And clients no longer hold the permanent cloud credentials and identity is cryptographically verified. So it's a huge step up for us. So in terms of what's coming next, both in upstream of Gravitino and Iceberg, one thing is Auth Manager rewrite in Iceberg. So Iceberg current OAuth util is being replaced by a new Auth Manager, OAuth 2 Manager. So key improvement is like they're improving the refresh story to gracefully fall back. So it tries a refresh token first, then a token exchange, or it falls back to generating an access token. Currently, it's a bit hard to configure, and they're doing it proactively. And before the token expires, they'll proactively do all this automatically. And on Gravitino side, we are seeing some changes in group level RBAC. Today, we grant roles to individual users. With the group support, we could map the Azure groups directly to the roles. So, for example, if someone joins the data engineering team in the company, they just need to join the Azure group for the team, and they'll automatically inherit the right Gravitino privileges. So no per user management will be needed once we have this. And there are some improvements in the view authorization in Iceberg and Gravitino. So Gravitino already has the invoker security model, which is like when you query a view, you need access to both the view and the underlying base tables. But looking ahead, we both Iceberg spec and Gravitino are planning to support the definer model, which would let views run with the creator's permissions, which would be useful for data abstraction, like views that filter some sensitive data or PI columns and stuff. So yeah, these are some things which we are looking forward, which can improve our auth even more. Yeah, that concludes my presentation. I can take any questions.
Do we have any questions to bring up? Otherwise, you all move. I have a question. Yeah, thank you for the presentation. I try to understand like what business use case you were solving here about the authentication and authorization based on the token rather than like one particular person on the platform. Like you are a platform engineer, you are solving that issue. Like, could you little bit tell me more on that? What business use case you are solved with this?
So the business use case here is mostly about the security perspective, right? Like I mentioned earlier, we had uh, shared clusters where all the jobs run as same username because we couldn't provide an identity to that job. So if you are a data engineering team, all the jobs, even in dev or prod, it runs as Spark user because we couldn't distinguish that part. And we were relying on the pod's permissions to the object storage to distinguish what it can access. But since it's a shared cluster, let's say one job needs PI data access, you have to give that access to the entire cluster, or you have to create a separate cluster, right? So it's not a scalable solution. So with this model, we can have separate permissions and even credential vending. So you don't even need to give permanent permissions to the cluster to access any resource. So
Okay.
yeah, that's the main use
Thank
case.
you for like overall I was trying to know like what yeah you are absolutely right like we also use like PII information with in a banking and then definitely we need to create a separate cluster for that type of a user like this kind of a use case if we are using like Iceberg and Gravitino it can solve that problem. Okay, okay, yeah, sure, thank you so much.
I wonder if you, yeah. So yeah, like why did you end up choosing Graviton? And I wonder if you did evaluate other Rascanas like Polaris, which is also open source, it's like an Apache license. And then also, can you comment on the support for different cloud providers? I see you were using Azure, but not a lot of people use Azure too.
Yeah. So we don't use Azure for our cloud. We use Azure AD for just the authentication identity provider. So we are on like AWS and GCP. So yeah, we your question was why we chose
Yeah, the first
Gravitino.
why?
Yeah.
Yeah, the first one, why Graviton compared to like
Yeah. So
any features you were.
yeah, so Gravitino is also it's like a catalog of catalogs, so it supports more than Iceberg. So we had further use cases that we want to consider. Like I said, we are on multiple clouds, so we wanted some solutions like multi-cloud access. Or Gravitino offers something called file set APIs, which can access data across clouds. So Iceberg is just one use case, and of course, one of the factors is that it's open source. and it solved the auth problems that we wanted, like all the features that we needed. And the main reason is the outlook that it aligns with our future plans, right? Like the multi-cloud story. So there were some solutions to deal or tackle that, and that's why we went with Gravitino.